Thanks for coming. This is about a lot of things, but for the hackathon, this is about the Cosmos-SDK, which is a Golang-based blockchain framework. So I'll be talking about that, and it's a little intro and sneak peek about Lotion, which is a strangely named blockchain framework based on JavaScript. But before that, I'll give a brief intro about Cosmos, unless people know about Cosmos. How many people here know what Cosmos is about? Okay, thank you. It's about maybe a third or less. How many people know about Tendermint or have heard about Tendermint? Awesome, it's about half of you. Great, so this will be good. By the way, if you want to just get the files and the other things that are linked to, then just go to github.com/Cosmos presentations, and I made a nice folder somewhere, and you'll get access to everything. Okay, so this is the standard Cosmos presentation, so I'll talk a little bit about what Cosmos is about. Well, it started with proof of stake, right? Let's see. So it started with Tendermint. Tendermint is a Byzantine fault tolerance engine. So, you know, Bitcoin is proof of work. It requires electricity and mining in order to come to consensus. And in 2014, we realized that maybe there's some issues with that, especially when it scales and the price of Bitcoin goes up and the amount of energy required to secure the blockchain keeps going up as well. So, a lot of people at the time were looking at proof of stake solutions, but arguably a lot of them were flawed. And there was really no good solution until, I would argue, Tendermint, because Tendermint brought classical BFT algorithms from academia, which had been developed since the 60s and 70s, and kind of brought it into the blockchain context. So here's just a list of some papers. If you are a masochist, I suggest you read this one, because that's the one I read, and I was like, whoa, all the pieces are in here. So I was going to compete with Cryptsy with an exchange, and I just dropped it after 6 months of development because it's excited me so much. All right, so this is kind of how Tendermint works. It's really mostly a pretty picture because, of course, you have no idea what that means. But it's a round-based system, and it's a two-phase commit protocol. It's kind of like RAF, but it's like the RAF for BFT algorithms. RAF is not BFT, it's only fault-tolerant. Right? Okay. Here's some properties. This is what we're going to do for Cosmos. So Cosmos, the hub, is a blockchain that we're going to launch in about 2 to 3 months. Hopefully less than 2 months, because otherwise I have to shave my head. But with 100 validators, you can get 3-second block times. That's like every block to finality. So that's kind of the goal of Tendermint is to not only be a proper BFT blockchain engine, but also to be fast and to get finality proofs very quickly. And that goes into the whole thing about Cosmos and what Cosmos is about. But it's pretty awesome. It's agnostic. It doesn't know what transactions mean, so you have to provide the application that tells Tendermint what those transactions are. And that's what Cosmos SDK and Lotion are about, because those are blockchain frameworks that build upon Tendermint, where Tendermint is just a layer that provides consensus, peer-to-peer networking, the blockchain structure, RPC calls, and so on, and transaction broadcasting. That's it. All right. So what can you do with Tendermint? Well, I said that you can get proofs of finality quickly. So then what you can do is you can use that proof, turn it into a transaction that gets committed to another blockchain. So you can prove to another blockchain that the status of this blockchain is so-and-so, right? So that's how you get inter-blockchain communication, which we call IBC. That's a standard TCP packet, so don't look at that. But the idea is to have blockchains that talk to each other literally as if it were TCP/IP, because we're creating an abstraction where packets need to be processed in order, in sequence, just like TCP/IP. Roughly, this is how it works. So first, you have to prove to one blockchain that the last committed block of zone 1, or this blockchain, was some block hash with some set of signatures. And then you can also prove to the hub that there was a packet intended for hub 1 inside the state, the Merkle state of zone 1. So that's the idea. And this is kind of the Cosmos hub, right? So this way you can send coins from one blockchain to another through the hub. So, in reference to the whole, ecosystem of blockchains, this is what Cosmos is trying to solve. It's trying to provide a solution for kind of an extension to the sidechains idea. So in the sidechains paper, Blockstream talked about how you can have Bitcoin at the center and many sidechains connected to it. But what we're creating is a whole network, an internet of blockchains. Okay? Then the nice benefit of the Cosmos Hub is that it's Tendermint BFT, so it's really fast, meaning you can get inter-blockchain transfers very quickly. And it's multi-assets. It's kind of like Bitcoin, except the Cosmos Hub doesn't care about what token you have. It accepts any token. So then what do you get? This is, if you're familiar with the sidechains paper, you might be familiar with the idea, but basically you can get interoperability. So you might have some Bitcoins, and you might want to move them over to some privacy zone, and then maybe anonymize it for privacy and then send it over to an Ethereum smart contract, right? You can do all that with the same underlying token that's fully backed by the Cosmos Hub. So you don't need to worry about exchange rates because everything's fully backed. The other nice thing is scaling. So Ethereum is cool, but it's got a scaling problem, right? So one way to scale it is to have the Cosmos Hub and many Ethereum blockchains connected around it. So we actually have a product for this called Ethermint, which is going to go through a little bit of refactor to build it on top of the Cosmos-SDK, which I'll talk about shortly. And of course, here's just one example. There's a lot of people working on distributed exchange ideas like 0x and Misago and others. The exchange is not really something that we need to solve. We're very happy to support others in creating a decentralized exchange system, but really the point is that no matter what exchange connects to the Cosmos Hub, we can all share the same underlying infrastructure for security. All right, so that's us, but now I want to talk to you and show you some of the things that we've been building. So here's a demo application built on the Cosmos Hub. Can you see this? It's kind of small, isn't it? All right, so in designing the Cosmos SDK, this is like the fourth iteration of a framework. And the first one was Tendermint. Tendermint used to actually have the EVM baked into it, and it turned into Hyperledger Burrow. And then we had this thing called Basecoin, which is an example application built upon Tendermint, where we pulled the EVM out and made Tendermint an agnostic engine. And then we created the SDK to make a better Basecoin, but then we scrapped that and created SDK 2. So what I'm showing you is a fourth generation of a framework, and I'm happy to say that I think we've got it right this time. It's based upon a lot of things. It's based on Golang, and it's also based on the principle of least authority or object capability design. So that's why there are all these keys here. Here, I'll show you what I mean. Okay, so here's an example. This is like the global router of your blockchain. And you've got all these concerns. These are different kinds of transaction messages that the blockchain can handle. It's got your standard coin transactions. It's got something cool. I have no idea what that is. You can do proof of work stuff, apparently. And here's a sketchy one. It's sketchy because it's probably a malicious plugin in the ecosystem, but thankfully, it doesn't have any keepers as arguments. So even if this were to be a faulty, bad implementation, it can't really do anything because it doesn't have access to keepers, right? Here's the Ibc plugin. So the idea is that with Cosmos SDK, you can just pull in like an Ibc library, just plug it in as if it were some kind of like a library or something like that. And then here's a simple staking system. We're of course creating the actual staking logic that's not ready yet. So here's simple staking for you to get started. So let's see if I can try to explain what's going on here. So the point is to create a least authority system. And the idea is you don't pass things into any function or any module unless it needs access to it. And that way, because things don't have access to things they don't need, even if the thing is faulty or malicious or buggy, it's not able to wreak havoc on the entire application. So we designed with the Cosmos SDK with an ecosystem of modules in mind. So you can publish your own module and import them and add them to your route list. Okay? So let's look at, so I talked about Sketchy, how it doesn't have any keeper. The keeper is kind of like a ORM mapper, sort of, but with like additional functionality. So if you look at the implementation of the bank keeper, you'll see that it's got functions for sending coins from one user to another. Yeah. And in order to do so, the bank keeper, right, no, the bank handler needs an access to the coin keeper. And what else? The IBC handler needs an access to the IBC mapper, but sometimes it also needs to do things with coins, so it has access to the coin keeper too. So the things that don't have access to the coin keeper can't do anything about coins. Even if they were to try to import some global module, they just don't have any way to do anything because the state is not accessible here, rather because the state is passed through a context. So let's see. All right, so here's another part of the application. It's like a file system, right? So the app has a file system, and you can mount all these Merkle trees with certain keys. And only if you have an instance of the key passed in this app.go file can you actually access that store. And so, yeah, these are all IAVL trees, and IAVL stands for Immutable AVL tree. It's an alternative to the persistent tree that we've implemented. So if you want really efficient Merkle proofs, then that's what you want. Yeah, don't want to go into too much detail. Take a look at yourself. But I do want to show you this, just as a highlight. So one thing that we really made sure in the SDK was we wanted to make it easy to store things into the state, right? The Bitcoin has UTXO system, but it doesn't really have a Merkle tree, right? So Namecoin has always wanted a Merkle tree, but didn't quite put it in there. Ethereum has a persistent tree, but it's kind of limited by 32-byte key value pairs, and so Solidity kind of manages to do something around that. But then you have to use Solidity and stuff. Right? All right, so check this out. Arbitrary key value pairs get and set. You also get access to an iterator. Dude, it's awesome. Because this way, and it's efficient too, you can actually iterate over key value pairs. It's stored in order. It doesn't need to be hashed. The keys don't need to be hashed before you put it into a persistent tree because it's a different kind of tree. Right? It's self-balancing. And of course, we'll also implement the persistent tree on it as well. Anyways, and then there's like this whole notion of caching. You can kind of wrap a store. So if you want to experiment with things like software transactional memory, you can do that. The caching system is how we handle fee payments. So there's like before the handler, there's the ante handler, which is designed to help you make sure that you have enough fees to pay, that the sequence numbers right. And if everything's good, then we'll go ahead and run the next stuff. But if we run the actual transaction and there's some kind of panic in there, then we can roll back the stuff from the cache wrap and kind of revert to what happened at the ante handler, which was deduction of fees. Did anyone catch that? No. Okay. We're going to have a workshop tomorrow. We'll be here 2 p.m., so please come join us. All right. The other thing I'm excited to show off is this thing called Kamino. So in Bitcoin, you don't really have a encoding or decoding standard. Everything's kind of makeshift, right? In Ethereum, you have RLP, which is used in the communication layer, and another change I'm not really sure. What we've discovered is that protobuf 3 is kind of awesome. It does almost everything we want, but not enough that there's this distinction, this parity between protobuf 3 and the language itself. So we designed an encoding system that is initially based on Golang, but is really intended to be used in any language, that makes development fun. In protobuf 3, generally what you have to do is you have to implement your logic structures, and then you have to implement your protobuf 3 message schema, which generates its own message Golang files, and then you kind of have to translate between the two. And the reason why you have to do all that is because the stuff that protobuf 3 generates isn't quite suitable for your logic, right? So we just get rid of all that, and we've created Kamino, which is object-oriented, and it meshes really well with Golang, but will also mesh really well with any modern language. as soon as we implement the client's languages. And it's baked into the SDK, so you'll be able to see how it works. The best thing about it is, I think, you can register interfaces. So you can say, here's an interface type, and you can register concrete things that implement it. And there's this whole system of like including some disambiguation bytes and prefix bytes to do that. It's pretty nice. And of course, the reason why we want to use this for the blockchain context is because protobuf 3 and Kamino have forward upgradability. So if you ever want to upgrade your blockchain, then you want to use something like protobuf 3, which allows you to skip fields or add more fields. Okay, and then the last thing is I want to show you Lotion, which is the JavaScript framework. I'm just going to show you some screenshots that Judd shared. I kind of don't believe how simple this is, but here's apparently a chat app. That's a chat blockchain. And they said I should show this one. That's ridiculous. All right, thank you. We'll be here tomorrow, 2 p.m. Oh, and then